Hello and welcome to my video 6.1, Solving Equations with Inverse Operations. Alright, so a normal equation, if we have, let's say, bracket 2 plus 1 bracket times 6 equals 4, and just without an answer there, we have to find the answer. While normal equation, we use BEDMAS to help us with the order of operations. So in that case, we would do brackets, exponents, division, multiplication, addition, subtraction. So the first letter of each lines up with that. Okay, so order of operations using BEDMAS to help us remember. So brackets first, so 2 plus 1 equals 3. Then you times by 6 to get you 18. So that's good to remember. But when we are doing inverse operations, we're doing inverse BEDMAS. So our arrow goes the opposite way. We start with subtraction and we go to brackets eventually. Okay, we do those last. Okay, so let's just take a look at some of the opposite operators, because we're saying inverse operators or opposite operators, same difference. So if we're saying inverse operators, let's take a look at a couple operators and what their inverse is. Well, if you have addition, the opposite is subtraction. If you have multiplication, the opposite is division, and the same goes true for the other way around. So opposite of subtraction is addition, opposite of division is multiplication. Okay, so the opposite is also true. And the opposite of exponents, so I'm just going to draw boxes for this. Opposite of exponents is a root. So usually at this point in your lives, you know about squares, so or squaring something. So 8 squared is 64, 2 squared is 2 times 2 is 4. So squaring something and square rooting something, which is finding the opposite of that, right? So those are also opposites. Okay, good to know about, but we probably won't even get to this at all this year in grade 9. Okay, but it's good to know about for the future. So opposite of plus is minus, opposite of times is divide, opposite of to the power of is to the root of. Okay, so with all that information now, we're going to do a couple example questions really quickly, and hopefully with all the different examples, you can use these as a way of finding the answer to anything or reverse engineering any of this. Okay, so 3 times a number is 9. So 3 times, so I put a dot for times, a number, I'm going to put n for number, equals 9. Okay, so this is our equation. We got that from the letters, from the words, that's good. 3 times a number equals 9, or is 9. Okay, so if you just look at it, you might already be able to see that what the answer is. But because things get more complicated as we go, it's better to actually do the work and to show the work. And in class, I will expect you to do the work. So you do need to learn how to do this, not just find the answer. Okay, so remember, inverse operations. So step 1 is basically what do you want, and we always want variables. Let's put variables, which is usually a letter. Variables, and I'll put in brackets behind letters on left side and numbers, or here I'll put constants, which a normal word for it is numbers, on the right side. Okay, so that's what we want to do. Okay, so step 1 is just asking ourselves, what do we want? Okay, and this is what we want. Okay, so let's try to do that. How are we going to do that? Well, step 2. Use inverse operators to move, well, I'll just leave it like that. Okay, we know it's to move stuff. Okay, so in this case, let's try green. In this case, we have 3 times n, which is our variable. So we want to leave the n here, because it says leave it on the left side. And we want to move the number over to the right side. Okay, so the 3 we want to move over, so it's 3 times n. So we want to do the inverse of 3 times n, which is divide by 3, divide by 3. If we do it to one side, do it to the other. And then we're left with 3 divided by 3 is 1. So 1 times n equals 9 divided by 3 is 3. And 1 times anything is just anything, whatever it was before. So it's just n. So what happens is the 3's cancel out. Okay? So I'm showing you why that we are getting rid of the 3, but it's because we're dividing by 3. Okay? So that is all the work I need to see for that question. Okay, we're going to go a little bit faster from now on. So we've done a little bit of the preamble, we're going to go faster. 4 less than a number. So if it's x minus 4 equals 1. Okay, so we want to get the 4 over to the other side. So plus 4, which then means that x minus 4 plus 4 is x plus 0, or just x. And there's our answer. Actually, I'll write it like this, because this is how I want you to write it. Okay, here's the next one. You're going to add the 3. Okay, so this is where the inverse bedmass comes into effect. What comes first? Adding and subtracting, then multiplication and division. So first, we're going to add 3 to both sides, which cancels this. Get 4d here. 17 plus 3. So now we have 4d equals 20. Okay, now we can do the division. So there was a 4 here, 4d, right? It's 4 times d. So we have to divide by 4, divide by 4. That cancels that, and we're left with d equals 20 divided by 4 is 5. So d equals 5. Okay, next question, same sort of steps. Minus 1, 2p equals, so those two things cancel, so we have 2p left over. Then we have 7 minus 1. Okay, now if we simplify that, we get 2p equals 6. Now we want to get rid of the 2 by the p, so we divide by 2. If we do it to one side, we do it to the other. So p equals 6 divided by 2 is 3. Okay, next question. We want to get the u by itself, but I can already see that I can simplify something. So this is where we can actually simplify it beforehand a little bit. If you can see some numbers, add them together or multiply them together first. So I'm going to do that right now. 3 plus 4 is 7. Okay. Now we want to move over the minus 2. So we plus 2 on both sides. Okay, so then we're left with u. So minus 2 plus 2 cancel. U equals 7 plus 2, or finally u equals 9. Okay, and again we can simplify this ahead of time. So 2y plus 2y equals 4y. Just like if we said 2 apples plus 2 apples equals 4 apples, 2 bananas plus 2 bananas equals 4 bananas. That's what all that we're doing here. Okay, so we're just adding those together. Equals 16. And now we want to get the y by itself. So we divide by 4. So 4, 4 cancel. So we're left with, and divide by 4. We're left with 16 divided by 4, which is 4. Okay, and here is our last question, slightly more difficult question, but not too bad, where we're going to use something called the distributive property. Okay, so remember, brackets have to be done, or you can think of brackets having to be done last. So you can do either one of these two things. I'm going to show you two methods. The first one is doing it just like opposite bedmass, right? Brackets last. Okay, so if we do brackets last, we'll take a look at that. Okay, so in that case, we're going to divide by 2 on both sides. So this 2 and this 2 cancel. We're left with x minus 1 equals 2 over 2, or 2 divided by 2 is 1. Okay. Then what we can do is we can add 1 to cancel this out and give the x by itself. So minus 1 plus 1 equals 0, so we're canceling it out. X equals 1 plus 1, which is 2. So x equals 2. The other way you can look at it is like this. So if I just write it again. Okay, when you have a bracket, you can actually multiply in whatever is beside it. Okay, so we'd have 2x minus 2 equals 2. And then we want to add the 2 here, add the 2 to move that over. So then we have 2x equals 4. And now we want to move the 2 by the x over. So x equals 4 divided by 2 is 2. And look, they actually agree with each other. Okay, and I hope that this helps you guys. But I just want to say one last thing here. With any of these, this is the case, but you can substitute the number. So let's say we found n equals 3 here, right? N equals 3. We can substitute that in for n. So 3 times n, no, we're going to write 3 times 3, because that's what n equals 9. Is that true? If it is true, then we did everything correctly. Okay? So you can always double check these, but there are a whole bunch of example questions done for you. I hope that helps, and good luck.